Hello everyone, my name is Alexandra and I will be discussing the research on the evolution of the Channel Island foxes. Much of the natural history of the Southern California Channel Islands has been shrouded in mystery for millennia. Its inhabitants also seem to be elusive apparitions due to the natural destruction the island has suffered at the hands of non-Native Americans. One species in particular, which could have almost been considered a phantom of the past, was the island fox. The Channel Islands, unique in their biogeography, flora, and fauna, are a similar island model as compared with the Galapagos and their unique ecosystems that differ ever so slightly from island to island. There has always been much speculation about how the existence of these foxes on the Channel Islands came to be, as they are the only land carnivorous predator inhabiting the archipelago. Most of the research on the Orcaon littoralis and its subspecies began emerging in the 1990s when their existence was becoming threatened. Although the island foxes almost became extinct, it brought about an influx of conversation and research which ultimately saved them. The first time I ever visited the Channel Islands was approximately 10 years ago, right around the time the native fox populations were at an all-time low. I didn't know much about the foxes at the time and was content simply enjoying the surface beauty of these islands. Several years later, once I was in middle school, I became actively involved in my school's environmental association and throughout high school, which meant we would be camping on Santa Cruz Island for several nights every year. Before we went, our teacher explained to us the history of the island, its past human population, how it was used commercially for both oil, farming, and game hunting, and how those factors affected many of the indigenous species on the land. This is some of the old equipment that was left by the farmers and oil miners. Conservation has always been something I've been extremely passionate about, so once I learned about the low fox populations, I began to track their recovery through the years, visiting the islands many times. My most fond memories on the island were of the foxes, and with each passing year their numbers steadily and visibly increased, to the point where they would climb into my tent while I was asleep and sit on top of me. The public focus on the near extinction of the island fox has allowed for more research to be conducted on fox conservation efforts, as well as how they came to be on the islands and how the nature of their genetics changed over the course of 10,000 years. The island fox only lives on 6 of the 8 Channel Islands off the coast of the Southern California, and they are found nowhere else on Earth. Each island population is recognized as a separate endemic or unique subspecies. It is a descendant of the mainland gray fox and the largest of the Channel Islands' native mammals, but one of the smallest canid species in the world. The 4 island fox subspecies underwent catastrophic declines in the 1990s. On San Miguel, Santa Rosa, and Santa Cruz Islands, and Channel Islands National Park, the decline was attributed to predation by the golden eagles. The presence of non-native ungulates, such as pigs, as a food source, in addition to the DDT-caused decline of the bald eagles, a natural competitor of the golden eagles, facilitated the establishment of golden eagles as the resident breeders on the islands. By 2000, predation on the island foxes had resulted in population declines to 15 individuals on San Miguel and Santa Rosa Islands and less than 80 on Santa Cruz Island. In 2004, each of the park's national subspecies was federally listed as endangered. Initial research on the island foxes started with Paul Collins in 1991, who argued that Native Americans brought the mainland gray fox to the southern Channel Islands 3,500 years ago. Occurrence of the island fox bone material only in the middle to late period sites on the southern Channel Islands suggests that the Indians were probably responsible for establishing foxes on San Clemente, Santa Catalina, and San Nicolas Islands. Data in the archaeological record were used to determine when Indians would have dispersed island foxes. Collins goes on to state that examination of the fox remains in Channel Island archaeological sites reveals that the foxes were present on the northern Channel Islands prior to the arrival of the Indians 9,000 to 10,000 years ago. On the southern Channel Islands, foxes do not appear in the archaeological record until about 3,400 to 3,800 years ago on Santa Catalina and San Clemente Islands, and 2,200 years ago on San Nicolas Island. Results of morphometric and archaeological analyses both support a fairly recent post-Holocene introduction of foxes from the northern Channel Islands to the southern Channel Islands by Indians. Researcher Richard Frankham laid down the backbone for research about how the species diverged from the mainland in his 1990 study, Relationship of Genetic Variation to Population Size in Wildlife, which states small population size correlates with the small amount of land available, thus genetic variation is only limited to mass or quantity of the islands. His research shows a steady upward trend in the amount of citation, making him a pioneer in the study of genetics in small populations, which continues to be increasingly relevant today. In 1991, Robert Wayne published a genetic study on island foxes, which evidenced amount of variation is lowest for smallest islands and largest for the more massive islands. Archaeological and geological evidence suggests that the foxes likely arrived on 3 northern islands minimally 10,000 to 16,000 years ago and dispersed to the 3 southern islands 2,000 to 4,000 years ago. Gilbert Dennis's 1990 study on genetic fingerprinting, which supported the aforementioned research by analyzing the differences in genetically isolated mammals through genetic restriction fragmentation profiles that could be used to reconstruct past evolutionary relationships within the fox population. In small populations of genetically isolated mammals, differences among hypervariable restriction fragment profiles can be used to estimate relative genetic variability and to reconstruct evolutionary relationships and natural populations. Gilbert's research was heavily cited throughout the 90s, but began to taper off as new studies were released. Initial research acted as a foundation for the discoveries made on the island foxes in the first decade of the 21st century. In 2004, the island foxes were on the critically endangered list and were given a 50% chance that they would become extinct in the next 10 years. The rapidly declining fox population called for more in-depth research. Elena Angulo's 2007 study on double allele effects on the island fox provided insight that the small population had a low fitness and that population crashes were correlated with an increase in predation by the golden eagles. Angulo states that an allele effect occurs in populations when individuals suffer a decrease in fitness at low densities. If a fitness component is reduced, per capita population growth rates may decline, and as a consequence, the extinction rate is increased. She proposes that the allele effects could render fox populations more sensitive and may be a likely explanation for their sharp decline. Because fox densities in critically endangered populations were well below this level, removing golden eagles appeared to be a necessary measure to prevent predation-driven allele effect. She advised conservationists to be aware of the allele effects when planning the release of captive foxes. In 1999, Channel Islands National Park began an island fox recovery program that included captive breeding and reintroduction of foxes, removal of resident golden eagles, reestablishment of bald eagles, and removal of non-native pigs. This coordinated, organized, and highly focused strategy was able to reverse the certain extinction of an endangered population. Today, the population has recovered within the park. The trend and annual survival are currently monitored to ensure that the recovery continues and future threats to the park's island fox subspecies are identified. Following the remarkable recovery of the island foxes, researcher Jacqueline Robinson published her 2016 research regarding genomic flatlining in the population due to the near extinction of the foxes. The decrease in genetic fitness made this population a model for testing ideas about declining variations in small, isolated populations. Now that the populations of the foxes have surpassed their previous population levels, more research about their genetic drift and speciation has been introduced into the scientific community. Courtney Hoffman and Rick Torben have since been prevalent members in conducting studies on the island foxes. In Hoffman's 2015 paper, Mitochondrial Genomes Suggest Rapid Evolution of Dwarf California Channel Islands Foxes, the results of her research are consistent with the initial fox colonization of the northern Channel Islands without the aid of humans. She hypothesizes that the foxes were then translocated from the north to the southern Channel Islands by human means. Her research also involved dating of these fossil fox bones, producing dates ranging from 6,400 to 200 calendar year, however, post-dating human colonization of the islands by several millennia. Although one of these specimens is the earliest securely dated fox bones from the islands, these new data supports the hypothesis that Native Americans introduced foxes to all Channel Islands in the early to middle Holocene. However, a natural dispersal for the original island colonization cannot be ruled out until further paleontological, archaeological, and genetic studies are conducted. This research is evidenced by the studies of the fox mitogenomes, which indicated that they are closely related to the gray mainland foxes, and the arrival to the archipelago may have been due to a Holocene climate-induced range shift. These studies are in line with the first ones made, but now are more specified with the advent of technology and the greater focus on the archetypal nature of the Channel Islands and their inhabitants. In August 2016, foxes were removed from the endangered species list due to the relentless work of conservationists and researchers. Although the fox population almost went extinct, these drastic events brought focus to the fragile state of the Channel Islands and increased conservation efforts with all of the endangered species on the islands. Naturally occurring events on these islands can serve as a model and method of study that can be applied to greater issues occurring all over the natural world.